Last episode of Mobycast, we began our post-coverage analysis of AWS reInvent 2019. With a major theme of transformation, we walked through some of the key advancements being made by AWS to drive innovation now and into the future. From supercomputing to networking to AI and ML, AWS is proof that there is no compression algorithm for experience. In this episode of Mobycast, Jon and Chris conclude their special two-part mini-series on this year's reInvent conference. We finish recapping the big keynote sessions and highlight the major themes of this year's show. We close it all out by sharing our most important takeaways that you need to know. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Yeah, personal story. This is all really interesting to me because a friend of mine who you met, Nate Simons, he's an architect over at Nasdaq, and he's been involved with Nasdaq, which just has billions and billions and trillions of pieces of data that they look at and try to figure out, because he's in the risk analysis kind of area of Nasdaq, I think. So he's got to look across transactions and think about things. I guess Rob Hunt, who's the VP of Nasdaq, did a session. I didn't know he was doing this, but he did a session at reInvent this year, and he talked about their journey from on-prem, and that was when Nate was doing Cassandra stuff, Hadoop, to cloud-native data warehouse using Redshift, and then they went off of Redshift to using historical data in Parquet in S3 with Presto and Spark, and then they went back to a Redshift cluster with historical data in S3 accessible via Spectrum. Mm-hmm. So AWS lost Nasdaq's business, and it was still in S3, but lost probably a lot of money. Like that Redshift cluster that they turned away from was probably making them a good amount of money that they lost when they moved over to S3 with Presto and Spark, and then they won that business back when they brought in the Spectrum capabilities. So super interesting.
Mm-hmm. Yeah, just so much change going on there, and just part of this definitely goes back to like Amazon's one of their core principles of just customer obsession and just really listening to what customers are saying, right? So
yeah, and I'm sure Nasdaq can move the needle with Amazon.
Mm-hmm. Yeah, absolutely. Yeah, so another thing Andy pointed out is just storage performance is growing much, much faster than compute and memory. So since 2012, there's been 12x improvement in storage versus 2x in CPU and memory. I mean, we talked about this before, like with just MacBook Pros, where you can get an 8 terabyte SSD inside a laptop computer that was 4 pounds, right?
Yeah.
Like, just kind of crazy and mind-boggling. So another new announcement they had was Aqua for Redshift. And so this is basically, they say it allows Redshift to run 10x faster than any other cloud data warehouse. And so they've built a high-speed cache on top of S3, and it's using this custom AWS design chip to do so. If you're into using Redshift and you've got lots of data, like this is obviously something that's going to be very, very useful.
Cool.
Rounding out a couple more announcements in the analytics space, they have Ultra Warm for Elasticsearch, which is kind of like, instead of kind of having you manage like storage tiers and whatnot, it's doing it for you, where it's kind of key. You can have your indexes be, the hot data, and then other data be kind of more in this warm tier. And they're just saying it's going to save you 90%, and you're just going to reduce cost by 90%. So, if you're using Elasticsearch, sounds pretty good, right?
Yeah.
And then they announced they now have a managed Cassandra service. So for just like last year, they did the managed service for Kafka. This year, they've now got a managed Cassandra. So for folks using that, this takes away that undifferentiated heavy lifting and let AWS do it for you.
Right.
All right. So that was theme aspect 4. So the fifth one was I Would Walk 500 Miles, which is a song from the Proclaimers. Yes. An oldie but goodie. And this one was really all about like what they're doing in the AI and ML space. And again, no surprise, like this was a focus. I think.
I think for me, the main thing here is like SageMaker is here to stay, and it's pretty, it's good. It's a good way to do your experimentation and sort of prepare your models.
Yep, absolutely. So, I mean, just by sheer count, there were 6 new features or services all around SageMaker that he announced during this talk. And then some of the other AI services, they announced Fraud Detector, which is a real-time fraud detection system, Code Guru, which they kind of pitched as like, this is
everybody's so excited about it, but I don't think it's very real.
Yeah.
I don't think it is.
Yeah. I think at the end of the day,
it caused a lot of buzz. I heard a lot of hallway talk about Code Guru.
Yeah, sure. I mean, like, people who likes doing, I mean, I actually enjoy doing code reviews, but I don't think, most normal people wouldn't, that's not so much fun, right?
Yeah.
So it's LGTM, looks good to me as their comment, and, PR approved. And so the idea of having like someone else, a computer do the code reviews is definitely pretty attractive, but we'll see how this shakes out. I think right now this is really, for the most part, static code analysis along with a profiler, but I'm sure they'll, continue to work on this and improve it. And, who knows what it'll be, a couple years down the road. A couple other things, Contact Lens for Amazon Connect, which basically, so Amazon Connect is their call center product software. And Contact Lens is this now ability, you can auto transcribe and analyze customer calls. So pretty cool, pretty impressive. So you're handling calls from customer service support, and now Contact Lens will automatically transcribe those calls and be able to analyze them, whether it be for sentiment analysis or just querying on that data or whatnot. It's all, you get it kind of just by checking a box now. So pretty cool. And then Kendra, which we talked a little bit about before, where this is now search across all your enterprise data, documents, FAQs, whatnot, and then using natural language to query it, right, and to find it. So it's all being backed by this AI.
I was so excited about Kendra that I went and tried to play with it a little bit. And, my takeaway is that it's got a long ways to go to be useful. I couldn't even really connect it up to anything, because right now it only connects to databases and something else, which I didn't have anything ready to go, right? Like I didn't have a production database where I was like, oh, I'm going to plug in Kendra. I'm just going to go ahead and do this. So yeah, it feels like there's a lot of room for them to add. And actually there were several things that are on the roadmap for early, Q1 2020 that looks like it'll become more interesting.
Yeah. Yeah. So yeah, I mean, just from a vision standpoint, like,
it's cool.
This is what they're driving towards, like, and
love the vision.
Yeah. And they'll get there. And then the last section of the keynote was,
quick point on that.
Yeah.
Google tried this. They didn't succeed at it. They were trying to do it with an appliance, from what I recall, like put this appliance in your data center, and they just didn't understand how enterprises work. And, the anecdote I heard was that they were surfacing data to people who shouldn't really have access to that data. So customers weren't happy, and they couldn't really figure out how to partition the data properly in terms of RBAC, rules and visibility. So I think that, AWS is much closer to probably being able to understand customers and understand the enterprise. So I think they're going to have a better shot at it. If Microsoft is also doing this, I think, they're probably going to have an advantage over AWS in terms of just understanding how enterprises work, how they want their data to be searchable, and who should be able to see it, and also like how it's hidden away and what's available and what's not.
Yep. Yeah, indeed.
Cool.
Absolutely. So, and then the sixth part of the keynote was based on the Doors song, Break On Through. So break on through to the other side, which at the end of the day was like, hey, AWS, we're just going to bring the cloud closer to you, to where you're at. And so kind of Andy ran through like the various options that they have now. So there's VMware Cloud on AWS, right? Which is where you can actually run VMware on AWS. So most folks on-prem, they're using VMware to run virtual machines. And so it becomes this really seamless migration path of getting onto the cloud by being able just to run those same VMware VMs inside AWS. So that's one. Another one is Outpost. So they announced Outpost last year at reInvent. This year there was a lot of talk about it because it's now generally available.
Okay.
So this is where you can get a rack of AWS hardware that is delivered to you, put into your on-prem data center, and it's installed, managed, monitored all by AWS. You can access it through the normal AWS console, all made possible based because of the Nitro system.
I'm getting one for my office.
Sure, why not? Yeah, got a few $100,000 sitting around.
Yeah,
got to spend it. Taxes, end of year purchases to offset gains.
Right.
You bet. Yeah. So there's Outpost, and then another new announcement they have is for something they're calling Local Zones. And Local Zones, basically what it is it's Outpost running in an Amazon managed building.
Like a 7-Eleven. Like the 7-Eleven of AWS.
Sure. Yeah.
But it is kind of like that, right? Like, have you ever seen like an Amazon pickup location? They have
like
those
in a Whole Foods market.
Yeah, exactly.
Or the lockers. You mean the lockers?
Yeah. Yeah, probably. I mean, not that, but it's kind of the same idea. Like, let's bring the cloud into your local Quickie Mart.
Mm-hmm. Yeah, so with Outpost, you have a reduced surface area of services, right, that are available. So instead of like 175, it's like more on the order of like 15 of the core services. But yeah, it's extending the region to be even closer to you. So like the first local zone they're implementing is in Los Angeles. So, for folks on the West Coast, instead of going all the way up to Oregon or US West 1, I think is San Francisco area. You're now, if you're down in that area, like going to the LA area is going to be faster and less latency. So there's the advantage there. And so LA is the first one. There's going to be more.
Yep. Eagle.
And it's just pops. Basically, it's pops that are just closer to you.
Yeah.
With the various services. And then the last one that they announced is this new offering called Wavelength. And Wavelength is basically marrying up AWS hardware services with the 5G providers in the network. So this is really aimed at the mobile devices and then other devices that are connected over 5G, where they're really addressing the latency. Because right now, there's that latency. Like if you are on the 5G or you are on a cellular network, you first are going through all the cellular infrastructure, right? And going to I think there's like a city hub, then there's a regional hub before it actually gets onto the backbone of the internet, right? So there's all this latency before it actually finally makes it to the cloud. And so they're saying, well, they're addressing that by taking an Outpost, I think, and putting it right there at the cellular provider's networking infrastructure, so that you don't have to go out over the backbone, and so you can reduce latency quite a bit for these applications that may really benefit from that. So whether it be like gaming or something else, this is going to be it could be very, very interesting. Right. They did make during this part of it, they brought on stage the CEO of Verizon Wireless to really just talk about like 5G. And it's going to be kind of interesting because I think, I haven't been too terribly excited about 5G because it's like, we have 4G and like you can walk down any street, stream video, like no problem whatsoever. It's like, it feels like we have all the bandwidth we need. Right.
I hear you.
Right.
One of the things I think that 5G could help with, sort of immediately would be self-driving cars. Like if you could start to put some processing power into, say, like all the stop signals, like every interchange, then you could start to have safe zones for self-driving cars. Like, know that you're on the road, like what the signal is saying, like, that you're not driving up onto a sidewalk or something because you've got like processable information nearby that has low latency and is correct and accurate. So I think that's an area that could see some of that innovation.
Yeah, and at the end of the day, it may just be like this concept of like this is the new network, right? It's no longer you're not going over fiber, you're not going over copper. It's just like everything can be wireless over the cellular networks just because it's got the bandwidth and it's fast enough and the latency is low enough where it just works. And no wires is better than is better than wires, right?
So we've gone long already, but I think maybe we just blow this one out a little bit, Chris. Might as well finish up talking about reInvent, and there's a little bit more to discuss, I think. What do you say?
Sure. Yeah. So why don't we move on to the last keynote we wanted to talk about, which is Werner Vogel's keynote. For me, this was a little bit interesting just because it was shorter this year.
Yeah.
And also, it just there in previous years, like Werner, there was a lot of announcements, especially in the kind of like core technology developer ecosystem space. Like last year, there was a whole bunch of stuff around Lambda with Lambda layers and the custom runtime. And there was just a bunch of other stuff in that space, right? And this year in his keynote, there wasn't any announcements really other than the Amazon Builders Library. And so it's cool, right? I mean, so it's a collection of documents that basically are kind of like giving you the inside knowledge of just how Amazon builds software, right? So if you want to know about shuffle sharding and how that leads to better availability, right? Like there's now a paper in that in the Amazon Builders Library that you can go read about. But it feels like, I mean, a lot of that information I think was already out there in one form or another, and it's just like now here's just another place. So we have the well-architected tool to go to now. We have the quick starts area that they have. There is, I mean, there's several different places now where there's these repositories of know-how and templates and quick starts and getting started and whatnot. And this is just kind of adding to that. This is just feels like it's probably more of a...
It's like organizing.
Yeah, and like the information that's here is going to be more like from just an architecture, maybe in design standpoint, and less of a, just here's how you would put these pieces together, right, type thing to roll this out. So that was really the only announcement here as part of his talk. The talk really kind of boiled down to a couple different sections. One was on just virtualization and kind of where they've been and where they're going to, and that ended up just kind of pointing out like, hey, we started off using Zen virtualization, and we talked a bit about this in the VMs versus containers mini series on Mobycast, where how VMs are implemented. So it kind of talks about like using Zen as the original hypervisor and the problems with that, and how they've now have this Nitro system, which is just so much better on so many different levels, and I think we're just going to end up having to maybe we'll talk about that on a future episode of Mobycast.
We teased it enough on this one.
I know. There is actually it is really impressive. There's a lot of pieces to it, and it's just not something that we can kind of talk about in 3 minutes. But just other than know, like this is the future. It's enabling lots of innovation, and all the new instance types are using it. We've talked about the benefits that we get from a networking standpoint. There's a lot of benefits that you get from a security standpoint and other performance standpoint. So really, really, really key, a crown jewel for AWS.
For me, I think it's worth saying at least one thing, at least in terms of how I think of it. It's like all the stuff that's virtualized, like your disk, like your networking, like your IO, like your memory, all that stuff that gets virtualized, like that used to be managed by this hypervisor that lived, that ran in your processor. And now it's like, oh, what if you could take that and make your own, put it somewhere else and just have a whole processor just for dealing with that stuff. And that's essentially what Nitro is.
Yep.
Cool. We did it. That's deep dive on Nitro.
Yeah. Not quite, but yes. Hopefully we've laid the groundwork for that.
Yeah.
And then along with Nitro, I just talked about Firecracker, and, again, highlighting that is like one of the crown jewels that they've been working on that's really starting to pay off. So we talk about that. This is truly a lightweight VM. So it combines the best of both worlds. It's the security and the isolation of a VM, but the performance, the speed of a container. And the Lambda service is currently running on Firecracker. I already thought that Fargate was using Firecracker. I thought that's what happened when they had the big price cut back at the beginning of the year.
Yeah.
But it turns out, no, they're not. They're not on Firecracker yet. They're working on it. It's coming soon. But as of yet, Fargate is not on Firecracker. They're still running. They're spinning up a VM for every container on Fargate right now, which is not efficient at all.
No.
It's very expensive, right? So once Firecracker comes along, they're going to get much better density, and prices will come down quite a bit.
And
so
that's when we'll see the like Cloud Run competitor that we talked about before, the Google Cloud Run thing that can like automatically scale up and down an image, a Docker image.
Yeah.
Another thing though that stuck with me from that Firecracker announcement, or just from discussing Firecracker, was that a way to think of it is that there's all this cruft in a VM, all this stuff that computers have to do that you just don't need for most applications. So just things around dealing with lots of different devices, things around managing tons of different users. If you're just running a single process, like you don't need all that stuff. So that's why it really is. There's just less to virtualize. And that's why it really is a lightweight virtual machine. They literally just stripped out a bunch of stuff from a typical operating system that most processes don't need.
Yeah. It's like you don't need to virtualize the display.
Yeah.
Right? There is no display. So that's just not part of it. Yeah. So it's very much purpose built, and we reap the gains from a performance simplicity standpoint.
We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox.
And so then the rest of his talk was really kind of an architecture case study for elastic block storage, so EBS. And so just kind of talked about how EBS has a cell-based architecture. I think we've talked about this in the past. This is very kind of core to how AWS builds services, is they take the cell-based approach where you're partitioning up your architecture into individual groups that are fully contained, that stand alone by themselves, right? And then you use things like partitioning and sharding to break it up into cells. But the idea is that you're reducing your blast radius so that if if a database dies, then it only affects that cell. It doesn't affect the entire service. And so EBS uses this cell-based architecture, but they did run into the problem where they have to keep state of where the data is, and they call that their config master, and that ended up being a single point of failure, right? So it's like, how do we deal with this? And so this is the first time that they've ever talked about a technology that they call Physalia. This is their approach to solving that problem. So really what it is it's breaking up that database into millions of tiny little databases. And they think of this as colonies of cells. So like the whole like
jellyfish model.
Yeah. What's kind of interesting about this is that it really, like, this design came about from their thinking about the CAP theorem. And so the CAP theorem says, so there's consistency, availability, and network partitions. And you basically can have two out of those three things. So if you want to be, you can't have all three at the same time, right? Is really what the CAP theorem is telling you. So they knew that for EBS, consistency was very important, right? Because it would be bad if you're like reading from the disk and sometimes it's there and sometimes it's not there.
Right.
And then availability, obviously very, very important as well. So in order for this to work, they knew that they had to reduce the probability of network partitions, right? So they had to simplify the networking of this and reduce basically the size of the network between the nodes in this cell or colony, right? So to do that, to reduce the chances of these network partitions, that's where they went to this idea like, well, we're just going to have millions of these really small databases, and we're going to optimize the placement of those database nodes to be as close as possible to those nodes that need to read and write to that database, right? So you're reducing the size of the network between them. So kind of an interesting approach. It was, again, kind of like an architecture level type talk about just a really interesting, challenging problem and how Amazon is going about solving it. And so they've done this and they've implemented it and they've seen their EBS error rate go down significantly, and they have much better consistency now with those error rates because they've gone from this more centralized model to these millions of little tiny databases and reduced their probability of network partitions happening.
So what was your takeaway from that part of the keynote, Chris?
From the talk about this
Physalia.
I think it was just kind of like just demonstrating AWS's just, again, there's no compression algorithm for experience, and something like this really can only come from going through all the trials and tribulations and getting to the scale that they're at, that it's forcing them to address these problems and come up with really interesting solutions, novel solutions to things, right? And so it's just showcasing that breadth and that depth of experience that AWS has.
Yeah, I guess my takeaway is a little bit more cynical. I mean, I agree with you. That's true. But my takeaway is a little bit more cynical, maybe Gen X cynicalness. It's like, okay, so at the beginning of the keynote, they show Werner in a video and he's trying on t-shirts and they're talking about how, whatever t-shirt he wears sort of drives virality of some tweets or like, pushes up like tweet hashtags, right? Like people are talking about it. So what I got from that is like, he's a popular celebrity. He's a celebrity among developers. He absolutely is. He's got TV shows, right? The guy's a celebrity within a reason, within a certain group, a niche celebrity. So then you get him on stage and you have him talk really deep down technical, telling you some secrets, and you have it go just over the heads of almost the entire audience. Just a little bit. Look, it's hard to understand him because of his accent. And every once in a while you can pick up something like, ooh, Physalia. Yes, that's very cool name. And oh yeah, blast radius. I get that part. But like he gets into the cap theorem stuff and it's like, whoosh, just went over the heads of everybody. Like, and like, oh, but I kind of get you again when he's talking about bringing the little databases close to the actual data. Like everyone kind of understands that part. And then the feeling that everybody's left with is, man, that guy is so smart. And that's the point. That's it. That was to make developers frothy. That's all it was. It wasn't anything else. It was just marketing. Just put a guy that's famous up in front of people and talk about fancy schmancy stuff so that they get all frothed up and go home and say how awesome AWS is. That totally is it. I mean, that's maybe the point of the whole conference, but it's not, right? Like we have actual jobs to do and we have to get our work done. And we have to learn how to do AWS stuff. But the cynical me, like that was the takeaway from that keynote is like, there wasn't anything new. There wasn't anything different, that he talked about. So let's just show off my smarts so that you love me more. And, you tell your bosses about me.
It's like, definitely a little bit more cynical view than mine. I think kind of paradoxically, both viewpoints are kind of saying the same thing. Just coming from different angles, right? So it's like, hey, AWS, they're faced with some just problems that most of us just will never see,
right?
Because we're just not working at that scale.
Yep. And so the actual detail there doesn't really matter to us that much, right? But it's cool. It's fun.
Yeah, I mean, like I said, for most people, it's going to go over their heads, and they're not going to be able to really appreciate it. Other than it's like, it is a cool name, and like, yeah, you've convinced me this seems really, really hard, and I don't understand it. Mm-hmm. So, most of the people in the room probably fit in that category, but
not most of our listeners, though, right? Because we're doing it. We're bringing everybody up. Yes, we're leveling up.
Hopefully hopefully we're bringing you along.
Yes.
So, all right. So that covers like the keynotes. So the three major keynotes. We've gone through all that stuff. So maybe now we can just kind of just tease out like, okay, just what's the takeaways from this, and what are some of the eye openers. And so for me, Nitro system,
Nitro.
Yes. We've talked a lot about that in the recap, and it's just this is like again, it's a crown jewel for AWS. they've invested a lot into it, and it's really going to be like the backbone for innovation going forward, and it's really going to enable a lot of amazing capabilities, new instance types, new applications, just immense amounts of computing power, and then really just taking AWS just all over, just everywhere it is, which kind of leads into another kind of like takeaway for me was just AWS is everywhere now. So it's all the way out on the very, very edge, with things like Lambda at Edge and their IoT initiatives, like with Greengrass. It's on-prem now with AWS Outpost. It's near-prem with AWS Local Zones. It's in 5G now with Wavelength. And then, of course, it's still in the cloud, right? With what we're used to. So it's literally it's coming to you, right? So if you're not going to come to it in the cloud, it's going to come out to where you are and be closer to you. And so it's just this really broad spectrum of coverage, and that will just continue, right? It will just continue to blend in. I mean, I wouldn't be surprised if they come out with AWS laptops, right? That have stuff built right into it. I mean, why not? Right. And it's like the perfect developer machine if you're working on AWS or something like that. Another big theme for me, which is just like the importance of AI and ML, and particularly with SageMaker. So, like I said, they had a lot of announcements around SageMaker, and at the end of the day, they've turned SageMaker into a complete, full-up developer platform. So they now have a SageMaker IDE. They have
debugger.
This concept of debugger. You can save your projects as a collection of experiments. You can collate all the artifacts around those experiments. There's operational support for like monitoring your models once they are deployed to make sure that they're not drifting.
I mean, this is huge. Chris, think about this. Like, as you said to me, AI ML practitioner capability, like being able to get in there and do stuff with it, with, not necessarily coming up with new ways of making models, but training models and kind of according to like some recipe books and things like that, is baseline expectation for developers now, right? You got some data, better put some AI ML to get insights out of that data, do some categorization or some prediction. And AWS, like they have Cloud9, and people are definitely using Cloud9 a little bit, but they're really not touching VS Code or Visual Studio in terms of like IDE love, but they really have a shot at being the IDE of AI ML. They really do. And
absolutely.
That's maybe more important right now, isn't it?
Yeah. So, I mean, I think up till now, like developers, people in this industry kind of understanding AI ML, being able to use it as a practitioner has been optional. Definitely going forward in the future, it is required, right? This is changing so rapidly. It's becoming so highly capable and advanced, and it's just going to be ingrained in everything we do. Like you have to be up to date on this. You have to use it. You have to be able to weave it into your work. Otherwise, it's just going to leave you behind.
Yes.
So AI, ML, like get on it, people. Like if you haven't, like go do it. So, and there's a lot of great ways to get into this, right? It's a huge field and there's lots to learn, but you don't have to do it all at once. You don't have to go get a college degree in this. You don't have to go do, full up courses or whatnot. I mean, just start off like taking off bits and pieces. So go play around with Deep Racer. I've kind of like, you don't have to go buy the $400 car, right? You can do it all via the simulated environments, but go do the Deep Racer.
Was there about to be an admission of guilt there, Chris? And then you just dropped off.
If you remember last year during our coverage of reInvent, I kind of mentioned this, like really, like you guys are making this big announcement, like it's a big deal at Deep Racer. It's like a $400, car, toy type thing. Like who's going to go spend $400 to play around with the toy? And you're going to have like these competitions, and it's like, okay, whatever. It's like, just doesn't, it seems kind of out of whack with everything else. And so now I'm kind of taking a little bit of a pivot there where it's like, you know what? This is probably a pretty easy way. Like, you don't have to go buy the car, but like go use the software and tools, the simulations to go learn. Like this is an opportunity for you to go learn about how reinforcement learning works.
Right. Yeah.
Right. So go play around with it. Mm-hmm. by doing so, and by doing a simulation of getting a car to try to follow a track or whatnot, like you're going to learn about that. And so same thing goes with Deep Composer, right? So Deep Composer is a new thing they just launched. It's a keyboard where using AI to basically write music, right, and to play it. But you can also do that without the actual piece of hardware. And it's teaching about GANs, right? So general adversarial networks, I think.
Okay.
Right. So another part of AI ML that you can go learn about,
right?
By, just these tools and kind of, it's going to be fun, right? And same thing goes. So Deep Lens was something they announced 2 years ago, which is teaching you a bit about like how some of the AI ML techniques work for image recognition.
Right.
So go start doing this stuff. Start playing with this stuff, right? To come up to speed for it. Go see it. I don't know if Coursera still has the course on introduction to machine learning and kind of going all into, just the basics of it on how it works. But that was a really good course that was free. Again, I don't know if it still is, but if it is, I mean, I would definitely go give that a look. It's 15 hours of work. I think you did that one, didn't you, John?
Yeah, I did. Yeah.
Mm-hmm. Yeah. So start just if you haven't looked into AI and ML and if all this stuff is new to you, jump on it, because I don't know when it is, if it's 2 years from now or 3 years from now or 5 years from now or even tomorrow, like it is going to be pretty important to your job. Agreed.
Yeah. Well, man,
let's see.
Go ahead.
I was just kind of wrapping up just a few more things. So analytics was just a big focus of this reInvent.
Yeah.
I was really kind of surprised by just how much effort they've put into Redshift. I mean, that's been one of those ones that in the past doesn't seem to have gotten a lot of attention. And this year the spotlight was on it.
Yeah, it was.
Big time. So Redshift and data lakes, big focus for AWS. And then the last thing that really I've come around on is quantum computing.
Yeah, we did have to touch on this. This is so cool. I'm so glad that you came around on it. I mean, let's tell the story. Like there was a guy from D-Wave who came to give a talk at GlueCon, and I think I might have even talked about it on the show, how it was so interesting to see that they were building a little IDE, a little software development kind of kit for developers to be able to get some time on D-Wave, and there was like a D-Wave cloud. And I think at the time you were just like, come back to me when you can do something real with it. And now, what's your thought now?
Yeah. So, I mean, I do remember that conversation, and I was just, you were like, hey, isn't this cool? And aren't you interested? And I'm like, no, not really. This is still in the labs. It's science fiction. Like, this is not going to be real for, tens of years, 10 years, type thing. So it's like, I'm not even like, it's just not even on my radar, right? There's been so many technologies like that in the past where it was like, there's lots of buzz around it. And like one of it is like photon computing, right? Using light instead of electricity as the medium, inside of a circuit board. And light, the advantage being that photons don't interact with each other like electrons do. Mm-hmm. And, nothing came of that, right? There was a lot of buzz around it, and like there was stuff that was built in the lab that seemed like it worked and whatnot, but, it didn't go anywhere. And actually with quantum, there's been a lot of stuff there too, right? Like we see the articles about like, quantum entanglement and like time travel and how they got like these two quantum particles to, what they're calling time travel, where one was able to communicate information to another one that was like 30 miles away, but it's all under like these really weird like lab conditions type thing. So it's just felt really science fiction-y. Mm-hmm. And at this reInvent, AWS did announce Bracket, which is their new service for quantum computing. So giving you access in the cloud to quantum computers, like from D-Wave and IonQ and Rigetti. And so that kind of got me looking at that a little bit more. And as I looked at it a little bit deeper, it was like I was really surprised by how far along it really is. So, started off with quantum computers. They were, didn't have much capabilities. They only had a few qubits. And so qubits are kind of like the basic building block for a quantum computer as opposed to bits, right? So think of it, if you had like a 4-bit computer, like that's not very impressive, right? It's not gonna do too terribly much. And so it started off with just, had a handful of these qubits. Well, now the current state is that they're up to about 50 to 70 qubits in a quantum computer. And around 100 qubits is when you can start using algorithms like the traveling salesman and solve those kinds of problems with the quantum computer. And then,
that's big.
Yeah. And so that's right around the corner, right? I mean, if you look at just the way that technology, the way that we've seen it progress, and it's not necessarily linear, it's usually exponential. So 100 qubits is not that far away. At 300 qubits, that's where you can represent more numbers at once than the total number of molecules in the entire universe.
Nice.
Right? So
what's this chocolate going to do to my body?
Yeah, exactly. Right. So there's so much effort being put into this now, and there's just so much resources and experts. I mean, Google is a they're at the forefront in this. Microsoft is at the forefront in this, and now Amazon is getting into the game as well. So there's progress being made there. It's no longer just in a lab. Like, if you want to go play around with quantum computing now, you can do it. And it's
literally, I think like D-Wave will give you time for free. Like, you can actually go read up a little bit and go make something happen on a real quantum computer. It's pretty cool.
Yeah. I kind of think of it, like, I view this as like the same thing that happened with AI and ML. Like 5 years ago, it wasn't too terribly practical. And now it's like, we have there was a freight truck that just drove itself from California to the East Coast with 50,000 pounds of butter in it, right? and it drove the entire way, the self-driving vehicle the entire way itself. And it's like, if someone told you that was possible like 5 years ago, like that was going to happen, it's like, really?
Yeah.
I don't know. I don't know if I'd bet on that.
Right.
And I think it's kind of the same thing that's happening with quantum. I think, where we're at now, 5 years from now, we're going to look back and say, oh my goodness. Like, yes, this has been pretty game changing. So I think quantum is only good for certain classes of problems. It's not going to be a replacement for digital computers. So it's not one of those things where it's just like, if you don't learn how to be a quantum programmer, it's just not going to work out for you. But it is, you should take a look into it, and it's something to be aware of and to know. And it's kind of good to know, like, what is it potentially good for versus what it's not. And just it's going to be a complement to the technologies that we have.
Right. Yeah. And because the pace of innovation is accelerating, and we've already decided that in software, it looks like the innovation is largely happening in the big companies, in the public clouds. But something I think some of our listeners will recognize when I say this is like, innovation is accelerating. So if you look to the past to gauge the pace of innovation and project that into the future, you will be incorrect. Like, you will underestimate how much innovation will happen in the next 5 years. If you look at the last 5 years.
Yeah.
And if you look at the last 5 years, it's like, whoa, so much happened. So more than that is going to happen in the next 5 years, which is just so hard to get your head around.
It is. I mean, I will not even make any predictions about what life's going to look like 20 years from now, right? Because it's like, I really do think it's going to be so completely different than what we can imagine.
Great. Yeah, I mean, me too. And I think hopefully what's coming out a little bit is how we were, both of us, inspired by reInvent. So it's a great conference to be at. Glad you could listen to us go on and on about it.
Yeah, absolutely. Yeah, sorry it was so long this week, but a lot to cover, and really good one. And if you haven't had a chance to go to reInvent, definitely get it on your calendar.
Yeah, we'll see you there next year.
All right. Thanks, Jon.
All right. Thanks, Chris. Bye.
Bye.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/Mobycast.